For this question, we're making a comparison to the planet Earth from the planet Earth to the new planet that was discovered. So let's start out with our Earth. Our Earth has a radius of RE. It has a mass of ME. It has a density of RE. And it has a GE, gravitational field strength, equal to 10. The new planet has a radius twice as large. So its radius is 2RE. Its mass is mass of the planet. Its density is 2/3 rho E. 2/3 rho E. The formulas we're using in these cases as we're looking for the gravitational field strength is G equals big G, mass of the Earth over R of the Earth squared. And if we wanted the mass of the Earth, well, let's go over to the planet first. So the planet, we have the same relationship. G of the planet is big G, mass of the planet over mass of the planet squared. But the mass of the planet is unknown to us. And the radius of the planet is twice RE. So that gives us G, mass of the planet, over 4RE squared. So next we're left with finding the mass of the planet. Well, what we know is the geometries of the planets, which allow us to figure out the velocity, or the volume, and that's related to the density. So we know 2/3 the density of the Earth, because the density of the planet. Now we'll just start right out with that. Rho planet equals mass of the planet divided by the volume of the planet. And the rho of the planet is 2/3 rho of the Earth, is the mass of the planet divided by the volume of the planet. Well, the mass of the planet, the thing we don't know, is 2/3 rho E times the volume of the planet, which is 4/3 pi r cubed, which is RE 2RE cubed. Well, that gives us a mass of the planet. We'll pull out the numbers here in the beginning. Is 2/3 times 4/3. 2R cubed, RE cubed is 8RE cubed. So that is 8, then rho E pi RE cubed. That's the mass of the planet. So now we can put that back into our equation up above, and we have GP then is big G times the mass of the planet, which is 8 and 8 is 64, so 64/9 rho E pi RE cubed. Or we need to know how big it is in absolute terms. So how big is this? We need to get rid of it somehow with rho E's and PE's and so forth. And we know how big the G of the Earth is. So we know how large that is. We go back to G, and we can find ME. Oh, go back to the density. We know rho E is ME over VE. And therefore, the VE, ME, mass of the Earth is equal to the rho of the Earth times the volume of the Earth, which is rho of the Earth times 4/3 pi RE cubed. That gives us a G then, a G of the Earth equal to big G. Mass of the Earth then is 4/3 pi RE cubed rho E. Well, then we can express these as a ratio. How big are they compared to each other? Well, we have big G, 4/3, rho E, pi, RE cubed. See the RE cubes cancel. I left out some things here in my haste. It was GMP. The M is so long we forgot the 4RE squared. And over here we have the 4RE squared as well. Or RE squared. So now we could do some canceling. The big G's cancel, of course. The pi's cancel. The rows cancel. These RE cubes cancel. And these RE squareds cancel, which leaves us with a GP to GE equal to 64/9 multiplied by the reciprocal times 3/4 over times 4 over 4 from up here, the numerator. And this goes into here 16 times. This is 3 times. And this here is 1, and this is 4. So that gives us 4/3 GE. Well, GE is 10. And that's about 13 and a little over 13. Giving us choice 3. Giving us choice 3.